Oh, I
I
was
did
about
the
to ask. Yeah, okay.
I did the recording, but so it was unable to build the file.
Yeah, if you don't
Okay,
mind, can you share the PPT that you showed in the class?
sure, sure.
Yeah, thank you.
So I will share you the file, pics, pics of the files. Okay, each and every slide.
Yeah,
Okay.
thank you.
And also, it would be great if you can share the recording. Could you sort out why it is not recorded properly?
Yeah, sure.
Yeah, thank you.
So first class, you guys have received the file, right?
Yeah,
Okay. So only yesterday's class was not recorded properly. So today I will make sure
I
it
knew
records well.
you sent the link, but I haven't opened the first
Oh,
class.
okay.
You did share the normalized thing, I guess.
Oh, yeah.
Yes.
Did you
Yeah,
check?
it's not the first class, it's the second class, right?
Yeah. So first class is mostly just like introduction and all, right?
Yeah,
So that's why I didn't send it.
yeah. Then we got it.
Okay. So make sure you download it. So within a week. So when I sent it, okay.
Oh, oh, do we need to?
Yes, you have to, because so I'm storing it in my Google Drive. So size of Google Drive will become high, right? So it
16.
won't allow me to, yeah, it won't allow me to upload the new files.
Yeah.
So make sure you download it within a week or 10 days.
Yeah,
Okay.
thank. Yeah.
Okay. So like this will store the file information. Okay. So we can store any kind of file like a Word file, Excel, or uh, video files. So in video files, we have different types of file formats, right? So .3GB files or .mob, .vlc. So based on the video file, video tool we use to watch the videos. So we have different of types of extensions. So all those types of files will be stored in our database, and we'll store it in hexadecimal format. So to store that kind of data, we'll use binary data type. Okay. So to store pictures, media files, docs, etc. We'll use this data type. And to migrate the data from one platform to another platform. Okay. So like one platform to another platform, nothing but, so if you are maintaining the data in Excel and you are storing the file data in one cell, and if you want to migrate it into SQL Server or any RDBMS thing, so we have to convert the data file into binary data, and we'll have to store it in a data format. Sorry. And timestamp. Okay. So don't think timestamp nothing but it's a time. Okay. So timestamp defines, so indicating the activity on a table. Okay. And known as row version column. Okay. So row version column nothing but, so for every single record, there will be a unique entry within that column if you use the timestamp data type. Okay. So just assume, so you are inserting a single record into employee table. So it will give you a unique row version ID to that employee. So I will give you a scenario. Okay. So for example, so when it helps, mostly nothing but, so I'll show you. For example, we have employee table and we are clubbing multiple branches. Okay. This is branch one employee details. Okay, so we have information like this: ID and name, location, and salary, and we have same information in branch 2. Okay, so just assume we have 2 branches and it has employee details. Okay, so you are inserting branch to, and you want to club the whole information and you have to maintain a single table for all the branches. So you thought like that. So to main, whenever we are converting all branches information and you are maintaining a single table, you have to club all the data, right? So branch 1, branch 2, branch 3, branch 4. So how many number of branches you have? So those many tables you have to club and you have to maintain a single table, right? So that time you will do the bulk inserts. Okay. And ID, coming to the ID. So we'll have the employee ID like this for a branch 1. So ID, name is John, and the location is California, and the salary is $1,000. And like this, we have 2. His name is David, and he's from New York. Okay, and his salary is 2,000. Okay, so like this, we have different employees in branch 2. So whenever we are clubbing n number of branches, so we have to store the information like this. So branch 1 details here and branch 2 details here. And if you see, the IDs are same, 1 and 2 and 1 and 2. Okay. To maintain the uniqueness across the data, we'll have a row version ID. So row version ID nothing but its data type is timestamp. So whenever the new record is inserting, okay, so it will create a ID here. So like 1, 2, 3, 4, and it will be in hexadecimal format. Okay, so like A, B, C, and 1, 2, 3, and 1, 2, 4, A, 1, 2, 4. Okay, it is not that much readable in format. Okay, so for example, just assume that. So this is the branch 2 details, right? So in case if you are in updating the branch 2 details and we have to update the combined table, right? So we don't know. So which table is which record is updated, right? So these details are maintained by branch 1 and these details are maintained by branch 2. But we have a master table in main branch and it has all branches information. But we don't know so which record is updated. For example, David is moved to Salt Lake. Okay, Salt Lake City. And we have to update that record, right? So don't think these numbers are repeated. So we will have the IDs like this, 3, 4, and okay. So if you have a timestamp column in your database or a table, okay. So whenever you do the updates or deletes or anything, so the row version ID will increment. So previously it is 124 AAA and 124, right? So whenever you do the change to single record, okay. So I'm just changing it to sort list. Okay. So it will be updated with new record value. Okay. So it will change to 126 a 124. So like this, it will update. So in case if there is any change in branch 2 details for employee number 4, okay. So now name is updated to David Raj. Okay. So now name is updated, right? So the row version ID will also be updated and it will become AAA 124 and AAA. So like this. So the version ID will be updated and these version IDs will be maintained not only here. So here also the values will be updated and here also IDs will be updated. Okay. So why they maintain in branch state nothing but so we don't know. So which value is updated? So if you look at the ID, it is always unique, right? So employee ID in an organization won't change unless and until if he leave the uh, organization and rejoin into the organization, isn't it? If an employee leaves the organization and rejoin, so we'll create a new employee ID. So he won't use the older version, older version ID. Okay. So if any data update happens on a single record, it will create a new version ID. And if the updates happen to the branch to details, it will create a new version ID. And ultimately, we have to update the main database details, right? So it will go and check. So this version ID is updated or not. So it will compare. So to compare each and every cell, instead of that, it will just check only the version ID. So is it updated? Is it updated? Is it updated? Like this, it will check for all the branch. So in case for this employee ID, this version ID is updated, then it will copy whole information and reinserts into this table. And it will check for branch 2 again, same. This employee ID and this version ID, this employee ID, this version ID. Okay. It won't check the remaining columns. Okay. Only the employee ID and the version ID. Okay. So if it compares all the values, it will take very huge time, right? So for example, if if an employee table have 100 columns and it has 1 lakh records as employee details. So just assume to compare each and every cell with each and every cell here. It will take very high time to compare each and every record and each and every cell. So to overcome that, SQL Server engine create version ID if they use timestamp data type, and it will become very easy for SQL Server engine to merge all the data with help of version ID wherever the changes are updated or deleted, anything. So for example, the record number 2 is deleted. Just assume that. So we won't do the deletion for employee table, just so we'll make them active or inactive flag. Okay. So just I'm showing the scenario. So in case if you deleted this record, okay, it will search for that employee ID and that version ID. So if that version is ID is not available, automatically it will delete the record in this main table. Okay, now you guys are getting right. So why you use timestamp? Okay, and also changed whenever a row is modified, any value. So row nothing but this whole row, right? Any change name, location, salary, or branch ID or anything. So if any column is updated, so the row version ID will be updated. And this value is not inserted by a developer. So this is auto generated by SQL Server engine. Okay. So we are no need to pass any value to the table.
So what triggers to check other tables will be?
So for example, just assume. So this is a server in USA and this is a server in India and this is a server in China. Okay. This is USA version and this is India and this is China. So in banking, so they will maintain a backup systems, isn't it? So while they maintain backup systems, nothing but backup servers. So in case, so if any natural disasters happens in any country, so they will use other backup the system and they won't maintain all backup and virtual system in same place because so if you maintain all the servers in a single location, for example, in USA, you are maintaining all the database. So unfortunately, we have earthquake in USA. So all the systems will become down and all the work in India, China, and everywhere. So wherever we have the branches, all the informations and all the work will down. So that is the reason they will maintain the servers and backup servers in different locations. Okay. So if you get a earthquake in USA, so we won't get earthquake in India, right? Or in China. So at least they will maintain two backup files. Okay. For example, so in the same scenario, so we have a employee information. Okay. Okay. So this is ID and this is name. And this is salary and this location. Okay. So whenever you are maintaining a backup servers, you have to maintain the data up to date in all the versions. So if you are using a live version in USA and you have to update the data, whatever we are getting in USA version to India also and also China. So you have to maintain same amount of data in USA and also India and also China, but some fraction of seconds difference. Okay. So why? Because USA will get fresh data and the data will be moved from USA to India and it will move the data from USA to China. Okay. So how do you identify this data is new and this data is old? Even you can't identify because in employee details we'll have lakhs and lakhs of records. So we can't go for record by record, right? So this record is old, this record is new, this record is updated, this record is modified. So you can't search the data for a table row by row, right? That is the reason we'll use a timestamp column. So timestamp column, we use a timestamp column. SQL Server engine will insert a unique ID into that column and it will maintain the versions for that single record. Okay. For example, so here employee 1 and his name is John. Just assume that I'm just showing you one example. Okay. Salary is $1,000 and his location is Hyderabad. Okay. So after appraisal, his salary is updated. So now his ID is ABC 963. Okay, just assume that. So right now his timestamp version ID is ABC 963. Okay, and so after appraisal, his salary is increased to 2,000. Okay, so we have a change in this record, right? So whenever we have a change in this record, automatically this timestamp ID will be modified, like ABC, AB, D, 1, 2, A. So like this, it will modify. So I'm just giving a sample ID. So it won't take so whatever the value I gave here. Okay. So whenever you do the update to this record, the timestamp ID will update it. And so whenever we are updating the backup servers, it will check for the timestamp ID. Okay. So is this timestamp ID is equal to this employee ID or not? So if the timestamp ID is not matching, because for employee ID, previously we have this ID. Right now it is ABD12A. And in India version, we have only ABC 963. So then SQL Server engine will understand. So so record is updated. So that time it will do the press insertion to India backup. It will do the press insert. అంటే కొత్తగా ఒక రికార్డ్ ని ఇన్సర్ట్ చేసి this record will be deleted in the backup server. Okay, same thing will happen for China. So that is the use of timestamp version. So now you guys are getting right. Any queries? Okay. And so as I said, this is not related to date and time. So and updated by SQL Server engine itself. The data within that column will be updated by SQL Server engine. So we no need to pass the information. It won't allow you to insert the data into that particular column if you use that column data type as timestamp. And we can use only one timestamp column per table. Okay. So if you want to use more than one, it won't allow you to create a table with multiple timestamp columns in the database. This is the thumb rule. Okay. Okay. Now we'll move to the next data type called bit. Bit nothing but it will store either 1 or 0 or null. So in which scenarios we'll use nothing but, so if you have a column called question oriented columns, okay, is active flag, is active record, or is active employee. So if you have a column like is active employee, so if it is a S, we'll store the value equal to 1. So if he is not an active employee, so we'll update that employee record as 0. So if you don't know about that employee, so we'll insert null. Okay. Or so in food apps. So you'll see veg, non-veg, right? So we'll have that option, right? So while inserting the customer details, so it will ask, are you a vegetarian? So if it is vegetarian equal to 1, nothing but he's a vegetarian. If it is 0, he's a non-vegetarian. So non-vegetarian, nothing but he's both. Okay. So if he didn't insert any value, it will insert the null value. Okay. To handle that kind of data, we'll use bit, true or false, or null. Null, nothing but you don't know, or unspecified. So that user didn't supply that information to the database. Now you got it right. Now we'll jump to the global unique identifier. Okay. Sorry. Global unique identifier. So this ID stores with 6 bytes of information. Okay. And only one column per table. And it will store the data in hexadecimal format. Okay. SQL Server insert new GID per each row using new ID function. So new ID function is a predefined or built-in function in a SQL Server. Okay. So the best example for GUID is barcodes. So if you go for Costco or Target, so for each and every product, there will be a barcode, right? So to maintain that kind of data, so just assume. So if you are purchasing a mobile, so మీరు ఒక మొబైల్ కొంటున్నారంటే there will be a number of mobiles. So this is mobile 1, mobile 2, mobile 3, and mobile 4, mobile 6. So to differentiate mobile 1 and mobile 2, so we have to use a unique number, right? So we have a unique number. So that unique number called as GUID, Global Unique Identifier. Okay. So by reading that barcode, the table will understand. So this is the one record of a product. So as it's shown, SQL Server insert a new record per each row, nothing but each product using new ID. So new ID is a predefined function. So we'll discuss about this in future. Okay. So new ID is a built-in function which helps you to generate a global unique identifier. So there will be a backend calculation by SQL Server engine barcodes. So these are the universal codes. Okay. And coming to the hexadecimal. Let me take a new file. So you guys are able to understand it, right? Okay. So in our data format, we'll have 3 types of data format. Okay. One is structured data and semi-structured data and non-structured data. Okay. So in whatever the data we are storing in our database is differentiated in 3 formats. One is structured data, semi-structured data, and non-structured data. So based on the behavior of your data, we differentiate the data category. Okay. So coming to the structured data. So what do we call a structured data? So what kind of data will store in a structured data? So structured data, nothing but, so whatever the data we store in RDBMS, Relational Database Management System. So whatever the data we store in RDBMS. So the best example is table. Because we have a structure for the data. So whatever the data we are storing, so it has a some structure, right? Like ID, name, salary, location. So we are storing it in a structured form. Okay. And coming to the non-structured data. Example is files and videos and documents. Like this, we'll have a number of types and comments and then text charts. Charts we can say. Okay. So just assume every day we'll do the WhatsApp chat, right? In the WhatsApp we'll have different types of chart inserts. So you'll send some logos, some emojis, some files, and also some documents, some videos. So to store that kind of data, and we'll use non-structured data tools like Hadoop or cloud-oriented systems like Data Lake, Spark, Databricks. So those kind of tools we'll use to store this kind of information. And this kind of information is categorized as non-structured data because there will be no particular structure coming to the table. So we have to store the data in rows and columns. That is a strict rule. Nothing but it is well organized. And coming to this information, so there is no particular organizing format. So chart, nothing but, so it is not only particular to text chart. We can have emojis, we can have video files, we can send the .exe files, any extension files within a chart, isn't it? We can send the PDFs, Word documents, videos, GIF files, emojis. So we don't have any structure to this chart box and also comments. Coming to the comment. So for example, a person is commented under a single window. Again, he will get one more comment. To that comment, we'll do the one more comment. So there is no particular structure. So we can do n number of nestings. Coming to the document. So in a single document, there will be different types of data. So we'll have the diagrams, we'll have the JPEGs in the document, and we can have some drawings and lines, and we can have different kinds of text within that document. So that is the reason we are categorizing them as non-structured data. So these data, best example is Facebook, Instagram, and so like this we have the uh, like this we have these organizations maintain the information in a non-structural data. Okay, to store this information, we'll use Hadoop. or data lake or data brick and AWS missions, cloud environment. Okay. So now we'll talk about semi-structured data. So before we going to talk about semi-structured data, so we'll see what is XML data type and why we need to store XML data type into our database. Okay. So just assume you have an account in ICICI. Okay. So this is ICICI Bank. Okay. And you have account called 1234. And this is HDFC Bank. And each bank will have its own ATMs, right? Will have its own ATMs. So HDFC Bank also will have its own ATMs. So this is ATM 1 and this is ATM 2 and this is ATM 3 and this is ATM for 1 of HDFC Bank, ATM 2 of HDFC Bank and HDFC Bank third ATM. Okay. So a account holder called 1234 have a ATM. Okay. So he wants to do withdrawal from ATM 1 here. So he wants to do the withdrawal here. So nowadays we have, we can do the withdrawal or we can do the check deposit. We can do the credit, cash credit also. So we have updates to the ATM machines, right? So we can do all the operations in a ATM center. Okay. So he wants to do the withdrawal in ATM 1. In ATM 1, he wants to do the withdrawal. And he wants to do the check deposit in ATM 2. In ATM 2, he wants to do the check deposit. And he went to HDFC Bank and he wants to do some withdrawal. Withdrawal of 1,000 rupees. Same account holder. Okay. So he wants to do withdrawal of 1,000 rupees from HDFC Bank. But he's the holder of ATM holder of ICICI Bank. Okay. But ICICI Bank system is developed by .NET language. So his ICICI Bank using .NET for his development software, for his software development, and HDFC Bank using Java. So just assume we have one more bank and he's using Python. Okay. So how a ATM is created in .NET version and you are going to do the withdrawal in Java mission. And you want to do some more action in Python version oriented mission. So how a system is understands how a different nothing but so how a .NET version ATM card will understand Java mission and Python mission. So to interpret these languages, we have a special language called XML, extensible markup language. So it is a common language for all languages we use. So .NET will be communicated in XML format to communicate with Java. Okay. So if Java version missions want to communicate with the .NET missions, so they will use a XML as a intermediary language. So if a Python mission wants to communicate with the .NET mission, they again use the XML mission as intermediary language. So if you have that kind of scenarios in your organization, will use XML data types to store that kind of data. Will use the XML data type. So I'll give you one scenario. Let me open a notepad. So how a .NET mission understands a Java built ATM card. So in the Java ATM card, the data will be stored like this. Customer. Okay. So this is a case sensitive. Okay. So it will be ended like this. Okay. And account number. So on so on so 1, 2, 3, 4, 5, 6. And will be ended with end tag. And his main branch Hyderabad. Branch and the balance amount. Okay. So like this will have n number of tags. Okay. Like the name and like account number, branch and balance. So we'll have n number of tags. So whatever the necessary information to do the withdrawal or anything. So any action in different language oriented missions. So this language will be readable by any language, Python, Java, or whatever the language you take. So whatever the development language you take. Okay. So that language will be readable for this XML format. So whenever you go to the ATM and if you do the swipe, so it will read this information. So he's a customer from HDFC Bank and he's the account holder of 1, 2, 3, 4, 5, 6. And he's from Hyderabad and he has 10,000 rupees in his account and he wants to do the withdrawal. WD withdrawal. And we'll specify the withdrawal. Withdrawal nothing but we are deducting. So it will do the minus 200. Okay. And So like this, it will update the XML data in its database. To store this kind of data in our database, we'll use the XML data type.
So XML we just use only to transfer data across the systems.
Yes, not the transferring, to communicate with other languages, missions. Okay.
Yeah.
Okay. So it's mainly used for the communication across multiple languages. Okay. Got it right?
Yes.
Okay. And we have one more, few more data types called spatial data types. So if you go for Uber, Zomato, Swiggy, or Ola, so there will be a customer who is moving from one location to other location. So, and if you want to store any maps, okay. So in that scenarios, we'll store the data, right? To store that kind of data, we'll use the data type geometry. Okay. So geometry, nothing but it's like a just location, so a small location, like longitude and latitude. Okay. And coming to the geography. So to store maps. So if you want to store US map, we'll use the geography. So if you want to store India map or any state map in a country or any city map, okay, so we'll use the geography. And coming to the hierarchy ID, okay, to get the level in a hierarchy. So there are many examples for hierarchical information. So take an employee information. So in every organization, there will be a CEO. Under CEO, there will be a different executive employees like CFO, COO, and some other people. Okay. Under CFO, there will be a different department. Under department, there will be employees. Okay. So under this again, we'll have, so we'll call this one is level 0. This is level 1. And this is level 2. And this is level 3. Okay. So nothing but this is hierarchy level 0, hierarchy level 1, hierarchy level 2, and hierarchy level 3. So if you want to store this kind of hierarchical information in our database, we'll use hierarchy ID. And coming to the one more example. Okay, let me take a fresh file. Okay. So for example, take our world. 1 minute. 1 minute, please. Sorry. Sorry, I'm back. So you guys can hear me?
Yes.
Ready.
Yeah. Okay. So just assume this is our world. Okay. So our world is divided into continents. Continent one, continent two, like Asia, Europe, like that. Okay. And each and every continent will have a country one, country, and country one, and a country two. Under a single country, there will be states. State one, state two, and state three, like that, and so on, so on, so on. So on. And under a single state, there will be counties or districts. So in India, we'll call them districts. District one, district two, like that. So if you want to store this kind of hierarchical information, we'll use the hierarchy ID. Okay.
So how do we store hierarchy in a table, Reddy?
Yeah. So the
It's
data, yeah. Let me show you. So it will store the data like this. Okay. This is continent one. So under, so better take, so this, just assume this is hierarchical column. Okay. So within this, data will be saved like this. Under world, so under world, it's a continent, continent one. And under that continent, so the data within a column will be shown here like this. Okay. Under world, continent one and continent two.
so
And
inside one column there are going to be multiple values.
yeah, it will look like multiple values, but it is a single value. Okay. That's what I'm showing. That's what I'm going to show you. This is country one, and this is a state one, and this is district one, and this is county one. Okay. So like this, it will store, and all this information is a single value for a single record. So like this, it will be repeated for all the counties. Okay. And even if you do the select query on this column, the data will be shown like this. Okay. So right now I don't have any a right table to show you the hierarchical data, but I'll show you. I'll show you in the next class. Okay.
Yeah, thank you.
So like this, the data will be stored.
If it is a hierarchy, is it a structured Still structured?
Yes, it's still structured. So like this, we can have different of hierarchicals. So coming to the family section, there will be so family. So under a family, there will be grandparents. Under grandparents, there will be their children, grandparent children, like our uncles, aunties, father, mother, and everyone. So, and for every family member, they will have their own children. So family tree, right? To store that kind of information. So we'll use the hierarchy. So these are the examples. Okay.
Okay.
We'll jump to the main thing. So now onwards, we'll start the real work. Okay. So in RDBMS, some rules are defined. So those rules are defined by the creator of RDBMS, Mr. F. Card. F. Card given 12 specific rules to maintain the data in RDBMS. So to maintain the data in a table, we have to satisfy those rules. Okay. Let me show you the rules. So if you search for card rules of DBMS. So these are rules are defined whenever the RDBMS are invented. RDBMS are invented by Edgar F. Card. So he defined some rules. Rule number 1, the data stored in a database, may it be user data or metadata. Metadata nothing but information about data. Data about a data nothing but metadata. Okay. Okay. And must have value of some table, cell, everything in database must be stored in table format. So that is one rule. And a guaranteed access rule. So every single data element value is guaranteed to be accessible logically with a combination of table name, primary key, a row value, and attribute name, column value. So no other names such as pointers can be used to access data. So these are all the rules defined by Mr. Card, and whenever we are doing the insertion to the table, it has to satisfy all the rules. Now we are going to discuss about integrity. Integrity nothing but correctness. Okay. So why we need to maintain the integrity in a table is, so if you insert the wrong data, we'll get the wrong data, isn't it? So if you insert a wrong data, so when you are looking for data, so it will be look like a wrong information. Okay. So these are the few examples. So employee ID, department ID, and passport number, driving license number should be unique. Just assume in an organization, if the employee ID is repeated, what will happen? a single employee ID is repeated to other employee, so one employee actions will be override with the other employee. So that is wrong, right? So to maintain that integrity, we have some integrity rules. And how we maintain that integrity, that all we'll see. And coming to the department ID. So in department details, we should have a single department ID. So we can't give a single ID to multiple departments. For example, sales department ID is 1234. So if you assign same ID to insurance department, is it a valid thing? No, right? And coming to the passport number, if you allocate same passport number to two citizens, a citizen will travel from one country to other country. And at the same time, if the second citizen want to go to other country, so that time it will show you the wrong details. అరే బాబు నువ్వు ఆల్రెడీ వేరే కంట్రీకి పోయావు మళ్ళీ నువ్వు ఎలా వచ్చావు సేమ్ కంట్రీలో అని అడుగుతాడు అంతేనా కదా సో టు మెయింటైన్ దట్ కైండ్ ఆఫ్ కరెక్ట్నెస్ ఇన్ అవర్ డేటాబేస్ we have some rules and regulations. Coming to the driving license and also Aadhaar card nowadays. And coming to the second one, transaction amount cannot be negative. Okay. So, for example, coming to the bank balance always 0 or greater than 0. So if you are going to open an account and if the bank is entered, your bank balance is minus 1,000 rupees. Is it a valid thing? No, right? To maintain that kind of integrity, we have some special items in RDBMS. And RDBMS will take care of that integrity while inserting the data into RDBMS. RDBMS just store the information, and while storing the data, it will check the correctness of data. So if you try to insert a wrong information, it will let you know, Are Babu, so you are trying to insert wrong information into this table. Yes, Arita.
So all these integrity rules will be defined by the company, right?
Yes.
Or is it the basic rule?
So few are basic rules and few are defined by
Company.
RDBM. Yes.
Okay.
Or a company or a system. So coming to the bank balance. So this is a system oriented rule. So these are all rules and regulations. We'll just follow. And how do we maintain the correctness? Nothing but RDBMS gave some features to maintain the correctness. Okay. So that is all. We'll see how we'll maintain the integrity with the help of RDBMS concepts. Okay. And the third one, the transaction date should be same as current date. For example, if you are doing a transaction today and if the system allocates yesterday date or tomorrow's date, so is it a right thing? No, right? And coming to the grades, grade A employees salary should be less than 5,000 and grade B employee salary should be greater than 5,000 and less than 10,000. And coming to the project ID can be 1, 2, 3, 4. For example, a new employee came to the joining the organization today, and a HR allocated a wrong project ID. So project number 50. But if you go and search for project details in project table, there will be no project number called 50 in the database. But an employee is allocated to project number 50. So that is a wrong, right? So how do we check that project ID is available or not? Okay. Coming to the account holder, in a bank cannot make more than transaction per day. So in case if a account holder do more than 3 transaction in a day, so some amount will be charged by bank. And account holder in a bank can withdraw maximum of 50,000 rupees as cash and 1 lakh rupees as check withdrawal and 2 lakhs rupees as transfer, online transfer. And when a transaction is altered, the difference between old amount and the new amount cannot be more than 10%. Like this, the rules and uh, regulations will be defined by an organization. To maintain this correctness, we have constraints.
So ready last one, when transaction is altered, the old difference between old amount and new amount cannot be more than 10%. What is this?
So
What do you mean altered?
altered nothing but it might be a withdrawal or a cash transfer or any online purchase or anything. Altered nothing but updated.
So if the person took all the money, how can that the new amount, I mean, it could be nothing, right?
Yeah, but for a few accounts, for example, uh, student accounts. So there will be some rules and regulations when they are holding an account for minors. So a parent can give some instruction to the bank account manager. So he can't do the withdrawal of 1 lakh, but he can maintain lakhs and lakhs of amount in his account. But he cannot do withdrawal more than 50,000 or 10% of his amount or 20% of his amount. So basically just he's mentioning the rule,
Okay.
just a 10%, 30%, 50%, just percentile amount.
Okay. Yeah. Got it. Thank you.
Okay. To achieve these rules and regulations, we have constraints. Okay. Null constraint, default constraint, primary key, unique key, foreign key, check constraint, and triggers, identity. And note, the above features are used to validate the data in SQL Server. And these constraints are common to all available RDBMS tools. Okay. Even if you go for Oracle, so these are all same. If you go for DB2, all are same. If you go for MySQL, same. PostgreSQL, same. So whatever the tool, so which is using RDBMS concept, they have to follow these integrity concepts, and they have to use these constraints: null, default, and primary key, unique key, foreign key, check constraint, triggers, identity. Okay. So we'll discuss about each and everything here in detail and how we use. Okay. And how we define a rule while creating a table and how it will restrict the data when we are entering the wrong information. Okay. So tomorrow we'll see. So what is the null and so what is the use of that and how to overcome not to insert null values into particular column. Okay. And why storing null values are bad and concerns. So tomorrow we'll cover these topics. So any doubts so far? Constraints. Monica, Spandana. So you guys are able to understand, right? So let me know if you are unable to understand any topic. So I will explain you with the different examples. So most of the time I'm giving real-time examples like banking and employee details and all. Okay. Any questions? No. Okay. We'll end the session here. Tomorrow we'll continue.
And also, Reddy, tomorrow is Saturday, right? So is there gonna be class?
It depends on you guys. So let me know. So if you guys are comfortable, then we'll have the class.
This week I will not be able to attend Saturday and Sunday.
Yeah, me as well. I can't attend on Saturday ready.
Okay. No problem because we don't have anything to practice. So we can skip it.
Yeah.
Okay.
Thank you.
So in future classes, at least we'll take one day off, either Saturday or Sunday, because you need time, right, to practice whatever the topics we covered in weekdays.
Yeah.
Okay. So at least we'll have one day off and make sure you practice all the topics we covered within that week.
Yes.
Okay. So in initial days, you have to complete all the tasks so that you can understand the future classes. Because if you go for advanced concepts, so you won't understand what is going on. Okay.
So did
So
you send any document to practice, Reddy?
yeah, I will give you a PDF. Okay. So after finishing this constraints, okay, I will share a PDF document with you guys. It has all the instructions to create tables and so what kind of constraints a column should have and everything, and how to create a database and all. So we have already covered, right, how to create a database and how to drop a database and all
Yeah.
in last class or
Yeah. Create
day
data
before.
and database, data object name.
Yes.
Ob-
Okay. Employee department is very diploma. 1 minute. Actually, for any hierarchy. So this is a row ID. So as I told you, right, for employee information, there will be a unique ID. That is row ID example. And coming to the bit salaried flag, nothing but is that employee is salaried or not, 1 or 0, because there will be a few people who are not salaried. For example, CEO, he will be compensated in terms of shares. He's not a salaried employee. Like that. Coming to the chairman of a organization, he's not a salaried. He'll get all the profits. And also current flag, nothing but is that employee is a active or not. And coming to the gender. So in the gender column, either we can insert M or F. So if you insert other than M or F, the data is not correct, right? So the gender column should always allow either male or female. Coming to the marital status. single or married or divorced. Divorced, nothing but he is married and divorced. So if again marries after divorce, nothing but he is a married. Or we can have a flag or bit oriented data type, like he is married. He is married, nothing but one or zero. One nothing but he is married. Zero nothing but not married. So if he defined any value, nothing but if he mentioned any marital information, so we'll insert nulls. Okay. Tomorrow we'll see one by one. Okay. So what is a null, what is a default key, and what is a primary key? So before ending a session, let me stop the recording.